8th graders, I'm going to keep this video short. This should be a fairly short lesson for you guys today. We're just going to go over some notes, put some more words into what we've been learning about in class. But mainly, you guys have nothing to turn in for this for a grade, okay? But that doesn't mean I don't expect you guys to watch this video and put these notes in. Also, be prepared, somewhere in this video, I'm going to drop you guys a little extra credit question where you guys can send me an answer in a chat in Teams, and I'll give you an extra credit point, which could help some of you guys have the difference between like a B and an A, okay? So you never know. So don't hesitate if you're already watching that to just send me the answer to that question. All right, moving on. You guys need to open your OneNote, and then you guys need to add these two images into your OneNote. So we've already have a magnetism section. We already have 2 pages, vocab and key concepts. I want you to add this third magnetism page, and then go ahead and paste those 2 pictures right in here. I'm going to go through them fairly briefly. And for the most part, you guys have learned how a magnet works, and you know what a magnet is, but do you guys know why something is magnetized? Okay, so that's one thing I'm going to talk to you guys about today. So magnetic force is the motion of electric charge or electrons resulting in repulsive or attractive forces between objects. So we know that if 2 charges are similar, they're alike, they repel each other, and 2 opposite charges are attractive, they'll attract to each other. Okay, you guys also have been told several times that electricity and magnetism are one and the same, and that's because of this motion of electrons. Okay, when we talk about electricity, you guys have a battery source that has a plethora of electrons in it. Okay, and when we connect some wires to that battery, those electrons are free to move away from each other. They all have a negative charge, so they don't want to be next to each other. They repel. So that allows them to be able to keep circulating through a wire, okay? Whether that be an electricity source like you see in your house or something you see in a gadget like a cell phone, okay? So it's those motion of electrons that causes electricity. Well, that's also the same case with magnetism. So again, we've learned a lot about magnetism, but have we actually learned why a piece of metal is a magnet, okay? Well, with that being said, it has that same concept dealing with how electrons arrange themselves and how they move. So we'll talk a lot more in depth about what an electron is when we talk about atoms and molecules later in the year. But for what you guys need to know right now is it's a subatomic particle, smaller than an atom, that has a negative charge. And as we know, like charges don't want to be next to each other. So if we have a bunch of electrons close to each other, they want to repel. It's just the same as a magnet, okay? When we're looking at a bar of magnet, there's a ton of atoms in there and a ton of electrons, and they all arrange themselves so they're kind of the furthest away from each other, and those little electrons sit in there and spin. And it's that spin of those electrons, and this is a lot more complicated theory or concept that you'd learn about more in like high school or college level. So we're not going to go into huge detail about the spin of electrons, but basically because electrons sit in there and spin and the way they arrange themselves, that causes a piece of magnet to have a north pole and a south pole. Okay? And just like I've kind of explained to some of my classes, is a magnet can lose its effectiveness. Basically over time, or depending on maybe if they're stored next to another magnet, those electrons in that magnet can kind of move around and rearrange themselves and cause that magnet to be less effective. There's a little machine that we have here. It's simple. That just kind of rearranges those electrons and causes them to have their magnetic force back. So as you guys know, magnets act over a distance. They don't have to be touching, just like gravity, for an object to feel the force of that magnet. The poles are the region where the charge is the strongest. So from the magnetism lab that we did a couple lessons ago where you guys sprinkled the iron filings over the magnet, you saw that a lot of those iron filings wanted to stick to the end. Okay, that's because the poles have the most magnetism there, furthest apart from each other, and so therefore they're strongest near the poles. Okay, magnetic field, you guys already know what that is. It's that invisible field surrounding a magnet, and it's where we have the force being exerted from. So it's why you don't have to have a magnet touching something for that object to feel its force. Okay, and again, that's strongest near the poles. So here's your guys' question for the day, and I'm going to answer it for you guys. All you have to do is just give me the answer to that question. So my question for you is, what's the world's largest magnet? Okay, so on Earth, where do we find the largest magnet? Well, the answer to that is actually Earth itself. Earth is one giant magnet. That's why where you guys hear the North Pole or the South Pole of the Earth, we're talking about how the Earth itself has a metal core that has a North Pole and a South Pole. But the fun fact about that is if you guys take a compass and you notice that the little north arrow is pointing north, Okay, does that make much sense to you? Because think about it, opposites attract and like charges repel. So would you have the north side of a compass pointing to the north side of Earth? Okay, we call it the geographic north, but in the science of it, our north pole is really the south pole of that magnet. And that's why a compass points north, because that north and south attract to each other. Okay, so we call it the geographic north, but really it's the south pole up there if we're talking about Earth as a big magnet. So again, send me a message in Teams telling me that Earth is the largest magnet on Earth, and I'll give you guys an extra credit point, which could help you be the difference between an A or a B or whatever letter grade you're talking about. All right, but moving on, we're going to talk really quick about electromagnets. Okay, so like I said earlier, electricity is where you guys have a battery source, such as a big supply of electrons that they don't want to be next to each other because opposites repel each other, or excuse me, like charges repel each other, and all those electrons have negative charges. They don't want to be next to each other. So when we connect a battery to a wire, those electrons are free to get away from each other and they move constantly through a wire. Okay, this causes a magnetic field around that wire because, again, they're very similar concepts. So what an electromagnet is where we take a coil of current carrying wire, so there's electrons running through that wire, and we wrap it around a piece of magnetic material. Now, when I say magnetic material, I don't necessarily mean a magnet. Okay, I mean something that has the capability of being a magnet. So for instance, a nail. Okay, a nail is made out of iron. It's not something that's normally a magnet. Okay, I can't go pick up a bunch of paper clips magnetically with a nail. But if I wrap this coil of wire around it a bunch of times, and then I connect it to a battery and electrons start moving through that wire, then it causes that nail to be magnetic, and we can pick up metal with it now. Okay, the second I disconnect that circuit and there's no longer electrons moving through it, it's no longer a magnet. So this little electromagnet can produce a strong magnetic field around something that's not normally magnetized. Okay, so we're going to be doing 2 labs with that in the next coming week where you guys are building electromagnets and figuring out how to make them stronger. And then you guys will be building an electromagnetic fishing pole and seeing who can catch the most fish. They're really just paper fish with a paper clip glued to the back in a little competition. Okay, last thing I really want to go over with you guys is just this picture of a magnet and magnetic fields. So you guys already kind of know what this magnetic field looks like, and you guys know that they kind of create these arches that connect the north to south pole. But what you maybe don't know is that they have a direction that they run in, and they always run from the north to the south. So they're kind of one-directional field lines when we draw them. So fields begin at the North Pole and extend to the South Pole. Okay, so that's really it for your notes today. You've watched this video. If you have that extra credit opportunity, send that to me in Teams. And then go ahead and turn in this assignment. Like I said, it's not for a grade, but it will show me, guys, that you at least acknowledged it was there and did it. And I hope you all are having a wonderful day. If you have any questions, let me know, and I'll talk to you later. Bye.